phase changes of water, solid to liquid to gas. This presentation will define important terminology and detail how exactly a substance, in this case water, changes phases. Before discussing how an object actually changes phases, there are several terms that must be first described. The first term is heat. Heat refers to the transfer of energy between two objects of differing energy levels. Heat will always transfer from the object with more energy to the object with lower energy. The term heat is sometimes used interchangeably with the term temperature, but these are actually not the same thing. Temperature, on the other hand, is a measure of how much kinetic energy the molecules in a substance have. The more kinetic energy they have, the higher the temperature will be. Similarly, less kinetic energy means that the temperature will be lower. Most people are familiar with the term melting. Typically, they think of ice cubes in their drink or a popsicle on a hot day. Technically, though, the term melt refers to the change in phase from a solid to a liquid. When a substance reaches its melting point, it begins to transform. It's the same substance, just different forms. Not all substances have the same melting point, though. Depending on the structure of the molecules, the melting point will vary for different substances. Freezing is the opposite of melting. When a substance changes forms from a liquid to a solid, it can be said that that object was frozen. Again, typically people think of water turning into ice cubes when they think of freezing, but any substance can change forms in this fashion. What people may not realize is that for any given substance, the melting point and the freezing point are the exact same temperature. Liquid water freezes at 0 degrees Celsius, just as ice melts back into liquid water at 0 degrees Celsius. To determine whether the substance is melting or freezing, the important factor isn't necessarily the temperature, but in which direction the phase change is occurring. Melting and freezing are two terms that we use to describe the phase changes between solids and liquids. There's also phase changes between liquids and gases. To describe those, we have two more terms to talk about. The first of which is boiling. The term boil refers to the change in phase from a liquid to a gas. The boiling point for water, for example, is 100 degrees Celsius. Just like freezing was the opposite of melting, condensing is the opposite of boiling. This means that a gas is changing forms back into a liquid. Boiling and condensing occur at the same temperature for a given substance, just like we saw before with the melting and freezing point. At 100 degrees Celsius, liquid water will boil into gas, just as water vapor will condense back into liquid water. With all of that terminology finally defined, we are now able to discuss how a substance will change phases. Ice is the solid form of water. And ice must remain cold, otherwise it will melt. How exactly does this happen, though? As heat is transferred into the ice, its temperature will begin to rise. It will continue rising until it reaches 0 degrees Celsius. Once it reaches this temperature, it will stay at 0 degrees for some period of time. The ice will not instantaneously transform into water the second it reaches 0 degrees. It takes a lot of energy to change phases, much more than it takes to simply change the temperature. During this period of time, the water molecules are gaining kinetic energy and the solid structure of the frozen particles is beginning to weaken. Once these structures begin breaking, the ice will start to melt into water. Once the ice is melted, the liquid water will begin increasing in temperature again, provided that energy is still being added to it. With no input of energy, a substance will not change in temperature or phase. When the water hits 100 degrees Celsius, it will begin to boil. Just like before, though, the change is not instantaneous. It takes time and a lot of energy to change phases from a liquid to a gas. The particles must become so excited that they continue to break down the structures between them. Once the bonds between these particles are broken, the water particles move about on their own in water vapor. Remember, though, that these processes are reversible. If water vapor is continuously cooled, it will eventually hit 100 degrees Celsius. At this point, it won't instantaneously become liquid water. It will take time. Bonds need to form between the water particles. Once this actually happens, the water will become liquid. After it's liquid water, it will continue to decrease in temperature. When this substance finally hits 0 degrees Celsius, the water particles will again start to form more bonds between themselves. Once the bonds are properly formed, we have solid ice. Once the ice is frozen solid, it will continue to lose heat and subsequently decrease in temperature. It is fairly apparent that there are some similarities between melting, freezing, boiling, and condensing, but there is one very important difference. That difference is the direction in which the energy is being transferred. An endothermic reaction requires the addition of energy. These reactions absorb heat to break the bonds of the substance's particles, indicating an increase in temperature. Melting and boiling, for example, are endothermic reactions. Conversely, an exothermic reaction gives off excess energy, indicating a decrease in temperature. Condensing and freezing are exothermic reactions. As it was previously mentioned, two substances that are at different temperatures will transfer heat energy amongst themselves. After they do this, they will eventually reach an equilibrium point. For example, if an ice cube is placed on a table, the heat energy in the air will transfer into the ice cube. Once the ice has melted and become liquid water, that water will increase in temperature until it is the same temperature as the room. If there is no difference in temperature, there will be no energy transfer, and as a result, no possible phase changes. Water isn't the only substance that can change phases. Any substance can do this. All these substances follow this generic pattern. The key temperatures for phase changes of all substances vary, but they will follow this pattern. The more energy added to or taken away from a substance, the higher or lower its temperature will be. As this substance changes temperatures, it will either break bonds or form new bonds and eventually change phases.